Hi guys, I'm Ernest and this is Ernest Sciences and Mathematics TV channel. First, I would kindly like to appreciate our members and also thank them for engaging us in the comment section. I also like to request us to be checking our description boxes for various links of other similar discussions, especially under a wide range of topics of mathematics and sciences. So in our discussion today, I'm going to look at some of the products of carbon. And of course, we're going to appreciate some of their uses in our day-to-day lives and some of the impacts which they're going to have, especially on our, particularly lives in terms of the environment and other aspects which we are going to look at. And in this particular case, these are the chief oxides of carbon. And in our discussion, I had mentioned that basically carbon is going to react with a range of elements, but mostly it's going to display the covalent capability of forming bonds with other compounds covalently. Now, in this particular case, we're going to look at these chief oxides of carbon, and these are going to be two in particular, which are going to be given as carbon 2 oxide and carbon. This is going to be a carbon oxide given as this. So this one we can give them in terms of, so these are going to be particularly carbon 2 oxide and carbon 4 oxide. Sorry for that. Carbon 4 oxide given as such. So we shall have this one given as this specific compounds which are going to be formed due to the reaction between carbon and oxygen in this specific case. So the first one is going to be achieved under limited supply of oxygen, whereby carbon is going to react with the oxygen to form this specific oxide. So the second one is going to be achieved from the excess supply of oxygen in the basic reactions, as we're going to see. Now the two compounds can be obtained through a various range of reactions, and particularly, as we said, this specific compound is found in the atmosphere in terms of composition of air, and therefore we can employ some of the methods which we had discussed in our previous discussion on the concept of liquefaction, distillation, etc., in order to perhaps or liquefaction in order to obtain it from the environment. Now we're going to look at this specific first one or the second one, which I've given in terms of carbon 4 oxide. And I've said this compound is going to be achieved through excess supply of oxygen, which is going to be reacting with, of course, oxygen in this specific, or oxygen reacting with the carbon in this specific case. Now, one of the methods, or there is a range of methods which we can use to obtain this one apart from liquefaction of air, which I've mentioned. So one of the methods is liquefaction of atmospheric air, which I've said, which is going to lead to different, of course, melting, different boiling points. Therefore, this is going to lead to its separation from the other components of air. So the next method that we can use to achieve this particular constituents of carbon, or the chief compounds of carbon, is through the reaction between a hydrocarbon and water. And particularly, we can give this one in terms of an equation for the reaction between perhaps water. So I'm just going to give this one in terms of water, and this is going to lead to the formation of carbon 4 oxide plus hydrogen gas given as such. So we can give this one in terms of perhaps a stoichiometric equation. So we're going to have gaseous methane reacting with gaseous or steam, and this is going to form carbon 4 oxide and hydrogen gas given as such. So the second way in which, or the third way in which we can obtain carbon 4 oxide is the reaction between carbon and oxygen, which of course I mentioned from our opening statement. So we're going to have this one oxygen in terms of atomic. So this one is going to be molecular. So we're going to have O2, and then we're going to have carbon 4 oxide given as such. So this is going to be gaseous. And then we can use another method which is basically a decomposition of limestone. And this is calcium carbonate, which we have mentioned, or we have mentioned in one or another in some of our videos, especially on the concept of synthesis of or industrial processes, particularly in the manufacture, the solvay process, manufacture of sodium carbonate. Of course, we had mentioned this specific compounds. So the decomposition of limestone, which is basically calcium carbonate is going to give us carbon 4 oxide and other products. So we're going to have this one in terms of an equation. We shall have carbon 4. This is a calcium carbonate undergoing decomposition, and that is going to form calcium oxide plus carbon 4 oxide given as such. So this is going to be gas, and this is going to be a solid given as such. So we can just have this specific equation, and that's going to give us a summary of some of the sources of carbon 4 oxide which we are going to come across. Last but not least, we can mention this specific one which we are going to come across also in some of our discussion. So that is through the fermentation of this is specific carbohydrates. So this is going to be fermentation, and this is going to lead to the formation of an alcohol, and of course, so basically we're going to have the alcohol for C6H5, and that one given as such, and this is going to be 2 units of carbon 4 oxide. And this is stoichiometric, so this is going to be a particularly. So let's have this one given as such. So this is going to form a product of course, this alcohol and carbon 4 oxide given as such. And we're going to come across this specific reaction in organic synthesis, and some of our videos we have already discussed this. So I'm going to put a link of this specific discussion in our description box. But to mention but a few, these are some of the processes which we can use in obtaining carbon oxide as a chief oxide of carbon. So the first one I've mentioned is the liquefaction of air. And the reaction between a hydrocarbon such as methane and water is going to, gaseous forms are going to lead to the formation of this specific product. And lastly, I've mentioned the decomposition of limestone, and of course the fermentation of this specific carbonate, hydrogen the carbohydrates, which is going to lead to the formation of an alcohol, and of course carbon 4 oxide given as such. So there are a wide range of uses which we are going to come across for this specific product of carbon. So some of the uses are going to be industrial one, and in perhaps in our natural processes such as photosynthesis. Now in this case, we are going to see that particularly this is going to be used in refrigeration. So this is going to be given as. So refrigeration, this is going to be used as a dry ice in our refrigerators, and then this is going to be also used in fire extinguishers. In the beverage industry for the manufacture of soft drinks. And then we're going to see that this one can as well be used in oil recovery processes in oil fields. So this is one of their uses, oil recovery in oil field processes. And of course, I've mentioned the concept of being used by plants. So this is going to be used by plants and algae, whereby we're going to see that this carbon 4 oxide is going to combine with water. So I'm just going to write this specific equation. So this is going to lead to the formation of this specific carbohydrates plus oxygen. So we have said that plants are the chief sources of oxygen, and therefore this is going to be the equation, the general equation, which is going to represent this specific reaction between carbon 4 oxide leading to the formation of this particular product. So in this case, these are some of the uses of carbon 4 oxide. But as we are going to see that these two chief carbon products are going to be having some impact on the environment due to their exploitation, and that's going to be leading to what we refer to as the global warming effect. And of course, we're going to discuss that one later in our discussions on various topics in environmental chemistry. Now, we are also going to look at the second oxide of carbon, which we had mentioned basically as carbon oxide that is achieved through the limited reaction of a limited supply of oxygen with carbon. And we're going to mention some of their uses or its uses in our day-to-day application. So this is going to be used in industrial processes as a reducing agent in furnaces. So these are going to be high heated components, of course, compartments which are going to be used in manufacture or reducing metals from their oxides and other applications. So this is going to be used in trying to prevent the oxidation of carbon to carbon 4 oxide, or in the absence of air. This is done in the absence of air in order to reduce the oxidation capability of carbon to carbon 4 oxide. So in this case, if we use an example of an iron ore, which is of course iron oxide, we're going to have this one reacted with a carbon oxide gas, and this is going to lead to the formation of the element of iron in liquid form. So this, due to high temperatures, these are going to be liquefied forms of the products, and then we're going to have carbon 4 oxide also formed as a product. So in this case, this is one of the applications as a reducing agent, and then we're going to use it in synthesis of other compounds, especially alcohol. So if we have carbon oxide reacting with hydrogen, so these are going to be gaseous states, and then we shall have methanol, the formation of methanol being given as such, and this is going to be one of the applications of carbon 2 oxide being given as such. So there are various other range of uses in terms of different compounds or different stages of applications for industrial use, and these are going to be perhaps in terms of what we have mentioned, and to list the last but not the least, we are going to see that in combination with the other of course compounds like methane and hydrogen and other combustible gases, the carbon 2 oxide is going to be used as a fuel in that specific combination. So that is it for now, guys. Kindly check our description boxes for various links of other similar videos, and a link of other discussions which we are going to do in mathematics, chemistry, physics, and perhaps biology. So that is it for now, guys. Bye, God bless you. Catch us in our next video.